Welcome to the Simple Machines class. In this class, we will learn about the 6 different simple machines: the pulley, the lever, the wedge, the screw, the wheel and axle, and the inclined plane. But before we get to one of these simple machines and doing experiments, we need to learn a few terms and a little bit of knowledge just about what kind of language and terms we'll be using for this class. So first, what is work? I'm going to show you a few pictures, and I want you to decide in your head, yes or no, if this is work. Okay, so here's the first picture. This policeman standing beside his police car. Is he doing work? Here's a girl reading. Looks as though she's comfortably reading a book. Is she doing work? Looks like this lady is on a coffee break. Is this lady doing work? Now we have a kid shoveling snow. Is he doing work? And this gentleman looks to be studying. Is he doing work? So let's go back to the first picture. The policeman standing beside his car. Is he doing work? The answer is no. He may be at what we call work, but he is not doing work in the scientific definition of what work is. He is not doing work. Let's look at this girl. Is she doing work? Yes. Yes, she is doing work. I want to pause right here to explain to you what work is when we're talking scientifically. Work is the pushing or pulling action. So you can see that the policeman is not actually pushing or pulling anything. He's standing there, he's resting his hand on the car. He's not actually performing work. He's not pushing or pulling something. And the picture of the girl holding the book, she is pulling up on that book. She's holding the book. So she is using muscle. She is using a force to hold up the book. So she is actually doing work. If you look at the picture of the lady at the coffee break, now that I've explained that to you, what would your answer be? Yes or no? Is the lady that's having a coffee break doing work? If you said yes, you're correct. Yes, because she is holding up the cup. So in order to hold up the cup, she has to pull up on the cup and lift it up. So she is doing work. Let's look at the guy studying. Is he doing work? It kind of looks like he's doing schoolwork, but is he performing work in the definition that we are using scientifically? The answer is no. No, he is not actually lifting something or pulling something right now. The last picture here, the boys are definitely doing work. It looks like they're doing work, and they are doing work. You can see he's in the middle of pulling up a shovel full of snow. So he is definitely doing work. So whenever you think of the term work in our Simple Machines class, remember, it's not like going to work, it's actually doing something. Here is your Simple Machines note page. If you haven't printed this out yet, I'd like you to pause this video and go get it printed. We need to fill in the definitions and for the terms for this class and on this Simple Machines page. Okay? So again, if you have not got this done, got this printed, get it, pause the video, print it, and come right back and we'll get started. Here we go. So work, we discussed this a little bit in the last slide, and work is using a pushing or pulling force to move an object. And in the pictures, if you remember, the policeman was not moving any kind of object or holding any kind of object up. In the picture of the girl very relaxingly reading a book, she was actually pulling on the book to hold it up. In the picture of the lady having a coffee break, she was pulling on her coffee cup to hold it up. The boy that was studying, or the guy that was studying, he wasn't actually pushing or pulling on anything. He was even resting his head on his hand, so he was not performing work. And the shoveling boys were definitely pushing snow, pulling the shovel. They were doing both of those things. So go ahead and get those 5 words filled into the blanks on your paper. Next, we have how to calculate how much work. It says use the formula. In order to figure out work scientifically, you multiply the force times the distance. This is something we'll be using more throughout class. So we will be talking more about what force is and how to measure distance in some of the different simple machines. So for now, just fill in these 3 places, these 3 blanks where it says work equals force times distance. Next we have machine. Machine is any kind of device that helps people to do work. So when we talk about these 6 simple machines, we are talking about devices that help people to do work. Go ahead and get those 4 words filled in. If at any time you need to pause the video to get your notes filled in, feel free to do so. Again, machine is any kind of device that helps people to do work. Now we're going to talk about 2 kinds of machines. First is the simple machine. Okay, the simple machine is any of the 6 machines that I mentioned at the beginning of class. Pulley, inclined plane, lever, wheel and axle, screw, and wedge. Couldn't think of the last one there. Those are the 6 simple machines that we will be talking about, and when they're all by themselves, they are called simple. The other kind of machines is compound, which is 2 or more simple machines. Just like a compound word is 2 smaller words put together to make one big word, like cup, cake, put together makes a cupcake. Well, compound machines are just 2 simple machines put together to make work even easier. So go ahead and fill in those blanks for the 2 kinds of machines, simple and compound, compound being 2 or more simple machines. Next we have MA. We will be using this abbreviation MA a lot during this class. MA stands for mechanical advantage. Mechanical advantage is how much less force is needed to do the work. So go ahead and get mechanical advantage filled in there so we know what MA is. And then we'll complete the definition by writing in how much less force is needed to do work. Next, you see where it says, to calculate MA, use the formula. We will be doing some calculations during this class, but I want to tell you right up front that this class is a science class, not a math class. So I want you to feel free to use a calculator. I don't want to have errors due to miscalculations when we're really trying to prove and see science happen. So calculators are completely acceptable for this class. So when we do calculations, feel free to have a calculator handy. So when we calculate MA, when we figure out MA for something, the formula is MA equals force out over force in. And when we say over, that means divide. So we're dividing those two numbers. And for each simple machine, we will see exactly where those numbers are coming from. Okay? So that is the formula that we use. And as you can see, this is just a simple ratio or a division problem. And most of the time it's fairly simple, but if we end up with decimals or something like that, we will absolutely get out our calculator so we don't make any kind of errors. Now, to give you the definition of force out and force in, so that we know what those are, the force out is the object's weight. Okay, sometimes it is called its load, okay, or the load that we're trying to lift. So how much the load weighs or the object weighs. This is often measured in newtons. For the first experiment or so, we will just be using pounds. It works just the same as it'll prove the science just the same as newtons. So for the first experiment, we will just be using pounds, but we will be switching to newtons at some point. So the force out is simply the weight of the object that you're trying to push or pull. Let me get caught up here. Sorry about that. I clicked too soon. If you need to get any of this filled in, go ahead and do it as I catch us up here. To review, work using a pushing or pulling force to move an object. To calculate how much work, use the formula work equals force times distance. A machine is any kind of device that helps people to do work. Two kinds of machines are simple and compound. Compound, which uses two or more simple machines. The abbreviation MA stands for mechanical advantage, which is how much less force is needed to do work. To calculate MA, we will divide force out by force in. As we said, force out is the weight, and force in is how hard you're pulling or pushing, which will be read most of the time by a spring scale. So when we pull on a string or something, we won't just be pulling with our hand, we'll be pulling on a spring scale between the string and our hand so we know how hard we are pulling. So go ahead and fill in force in there. And we will go ahead and move on to the first simple machine. So that last page is just some information that you will need throughout the class. So keep that definition page handy, because those are definitions and those are terms that you're going to need to know. And those will be terms that you will study in Quizlet throughout the course, okay, so that you know them. So we're going to move right into the student notes for pulleys, and after we're done with this page, or when we get down to the bottom here, then we're going to actually get into an experiment. So let's get the top of this page filled out. You see a picture of a pulley there, has several pulleys actually on it. What is a pulley? A pulley is a simple machine that consists of a rope that fits into a groove in a wheel. You can kind of see that in the picture there, that a pulley is a simple machine that consists of a rope that fits into a groove in a wheel. So go ahead and get that filled in. And it's a little bit long there, so you might have to write half of it on top and half of it underneath. If you need to pause the video to get everything written down, feel free to do that. Okay, and we're going to keep going here. The arrow tells us, what does the pulley do? It is used to reduce force necessary to move something. Okay, and reducing the force, we're reducing the work. Okay, we're reducing what it feels like to do that. Okay, it's making it less effort. So go ahead and fill that in. Used to reduce force necessary to move something. Now again, on this paper we have force in. And when we are discussing pulleys, the force in will be your hand. Your hand will be putting the force in. It's what the scale reads after the pulley. So it'll be your hand. The force in will be your hand. It's what the scale reads after the pulley. It's what, because your hand will actually be touching this scale. That is what the force in is, what the scale reads. Okay. Next we have force out, and this is the object's weight. Okay, what effort it takes to lift the object without any simple machines. Okay, so this is the effort to just lift it simply without any simple machines, just the object's weight. Okay. Next we have two more terms here, and one is fixed pulley. This is a single pulley and doesn't change the force needed. So we will see that in our experiment here today. We will see a fixed pulley, and it is just simply a single pulley. It has only one wheel with it. It's a single pulley that doesn't change the force needed. In other words, if the force needed to lift the object without a pulley will be the same with the single pulley. The only thing that a fixed pulley does is change the direction of the pull. If you're lifting something, you might be lifting up. If you tie a rope, put it through a pulley, then you'll actually be able to pull down instead of up. So it changes the direction, but not the force needed. Movable pulley is when pulleys move and create mechanical advantage. In the picture here on the side, the top pulley doesn't move, but in this system, the bottom pulley is going to move. So it is a movable pulley. When pulleys move and create mechanical advantage. When you're creating mechanical advantage, you're making the effort less. Okay, so mechanical advantage is load divided by the scale after the pulley. Okay, so we're going to figure out what the load or the weight is, and then we're going to divide it by the scale reading after the pulley, which is the same as force out divided by force in. And we will be starting to use R for force out and F for force in. Okay? You can think of R as resistance. Resistance to picking it up. It's resisting being picked up. It resists by 100 pounds to be picked up. So if you think about that as, weight as resisting being picked up, that might help you remember that force out the weight, it's resisting. Okay. So the next thing that we will be doing is our experiment. And that will be in the next video. So make sure you have these notes filled out. If you need to reverse the video and pause it to get everything filled in, that's fine. This is just some terms and things that we will be using for the class, and this page especially for pulleys. So, and as we do the experiment, a lot of these things will become more clear. So if some of this is like a lot of information, just hang tight with me. A lot of it will be made clear and be confirmed when we do the experiment in the next video.